This is a lesson on redox. Redox is short for reduction oxidation. It's similar to acid and base reactions, but instead of acids and bases competing for protons, protons are transferred, electrons are transferred in a redox reaction. So it's the movement of electrons which makes a redox reaction. One of the first things we've got to do, and this is also related to electricity, obviously, because electrons are moving. First thing we do is talk about oxidation number. By using and calculating oxidation numbers, we can find out what is being oxidized and what is being reduced. The oxidation number is the apparent charge on an atom. Kind of close to ionic charge, and for simple ions, that's what it is. But it also helps you figure out what charges are in polyatomic ions, all the elements. There are 6 rules. First rule, if it's an element in its natural state, it's equal to 0. The charge is 0. Sodium, chlorine, gas, anything separate by themselves in their elemental form is 0. The second one is a monatomic or simple ion. It's equal to the charge. Monatomic means 1, so if it's Na plus, the charge is plus 1. The oxidation number is plus 1. The charge is 1 plus, but the oxidation number is plus 1. If you have chloride ions, that would mean that the oxidation number is 1 negative. Okay. 3, fluorine, if it's in a compound, is always negative 1. If it's in a compound or if it's an ion. So CaF2 and NaF, which again is no big deal because on the periodic table fluorine is negative 1 charge. So these are both 1 negative charges. Fourth rule, oxygen is always negative 2 when it's in a compound, except for the substance we're going to talk about. So if you have CaO or N2O, the oxygen charge or the oxygen oxidation number is 2 negative. The exception is peroxides. Peroxides O2, 2 minus is a diatomic ion. The only 2 peroxides that you have to worry about are sodium peroxide and hydrogen peroxide. There are others, but those are the only 2 common ones that you would run into. Fifth, hydrogen is always, these should be 1 minuses behind. Hydrogen is always 1 positive. If leading, most of the time it is, H2O, HCl, these are all 1 plus oxidation numbers. Again, the exception is if it's trailing, then it's a negative 1, because positives are always there. There is something called lithium hydride. Lithium hydride, if it ends with an H, is a hydride. So lithium hydride, the hydrogen is a 1 minus. Positives always go in front, negatives always go in back. All others you calculate using the above rules. And it's really simple to do. It's not that difficult. If you have PCl5, what are the oxidation numbers of all the atoms? Well, you don't know what P is. It's X. There are 5 Cl's, and Cl has a -1 charge, or oxidation number, and it's a neutral compound. So that would be X plus -5, let's write it like math, equals 0, X equals 5. So the oxidation number of the phosphorus is +5, the oxidation number of the chloride is 1-. Carbonate, CO3, 2-. Again, we don't know what the carbon charge is, so it's X plus 3 times, let's write it in the math form, -2, equals, now, the charge on the ion is -2, so they have to add up there. And I did screw this up here. That's supposed to be -1. I'm not going to worry too much about it. Whatever way you do it, it's fine with me. I'm going to be picky about it, and I don't think the AP exam will be particular either. E equals -2, add 6 both sides, X equals 4. So here the oxidation number of carbon is 4. A couple more. Chromate, or dichromate. So here you have 2 chromiums, which you don't know, so that's 2X plus 7 times -2 equals -2. 2X minus 14 equals -2, add 14, 2X equals 12, X equals +6. So the oxidation number is +6. That's where I got it. One more. Fe3O4, which is the form of iron that you find in the ground. Magnetite, or I think it's magnetite, I'm not sure. So iron you don't know, so that's 3X plus 4 times -2 is -8 equals 0. 3X equals 8 divided by 3. Now, it is possible to get a fractional value, sometimes, not often. What really happens, what that means is there are 2 of these 3 ions are +3, and 1 is +2. The +3 plus 3 plus 2 is 8, and then divided by 3 atoms, so it's 8/3. Again, this is a convention. This is not really something that truly exists. It just helps us people to comprehend what's going on. Now, what is being reduced? We're using the above stuff to figure out what the oxidation numbers are and whether something's being oxidized or reduced. If it's being reduced, the oxidation number goes down. It's reduced. Reduced means going down. So it's reduced. And if the charge is going down, that means you're gaining electrons. They are electron absorbers. That means oxidized would be the opposite. The oxidation number goes up, which means it's oxidized, and it's not gaining electrons but losing electrons. So if you have zinc going to zinc ions, the oxidation number of zinc is 0. The oxidation number of zinc ions is +2. 0 to +2, the charge is going up, so that's being oxidized. Carbon dioxide going to carbon. We did carbon, no, we didn't do carbon dioxide. So this is x plus a -4 equals 0. So x is 4. So it's a +4 here, and this is carbon by itself. It's an atom, so it's 0. We're going from +4 to 0. That's going downhill, so it's reduced. VO2 yields VO3 2-. Okay, vanadium, we don't know. X plus -4 equals 0. X equals 4. Here, x plus -6 equals -2. Add 6, x equals 4. The oxidation number did not go up, it did not go down, so that's a neither, which is possible. Not all reactions are redox reactions. So if the charge goes up, it's being oxidized. If the charge goes down, it's being reduced. And if it does not change, it's neither. Now this is confusing, and I'm putting it here at the end. If you're easily confused, just kind of ignore this. If it's being reduced, that means it's an oxidizing agent. That means if it helps the oxidizing thing go. And then if it's oxidized, it's a reducing agent. Sometimes on chemical labels and stuff, they'll say danger, very good, strong oxidizing agent. If that's true, then you know it's being reduced. It's confusing because it's the opposite of the thing. I would say if you have troubles, ignore it. Just go with what's being oxidized, what's being reduced. That concludes this lesson on background of redox.